SpinQ Gemini Lab, the new generation quantum computing experimental teaching and research platform from SpinQ Technology, features miniaturization and room temperature operation. The device adopts a portable case design for transportation, making it easy to move and store. In practical use, the device can unfold into an open experimental platform. It can be powered up by connecting to mains power. The working status of each module is clearly visible. The hardware interface is convenient for plugging and unplugging, allowing connection to external devices. The hardware is controlled by an Android control system. When used or demonstrated by multiple users, it can connect to a vertical touch all-in-one machine. It can also be used by connecting to an Android tablet. The SpinQ Gemini Lab will come with various small tools for experiments. The real quantum system allows physical interaction, making abstract quantum experimental phenomena more intuitive. For example, changing the strength of the main magnetic field with a small magnet, observing how this change affects the Larmor frequency of spin, and how it changes the Zeeman splitting energy gap. The built-in arbitrary waveform generator can free control qubits. The interface will display real experimental data. There are several different samples available for changing according to the requirement of experiments. When changing samples, open the protective cover of the magnet module. Replace the sample tube. And then control different qubits in specific experiments to observe various experimental phenomena. Each experiment involving underlying operations presents the time domain and frequency domain original signals generated by the spin. Different types of experiments also have different graphics and charts. These visual results obtained from processing original data make professional experimental results intuitive and easy to understand. The radio frequency circuit system interface design is flexible, which can freely connect external devices such as oscilloscopes, signal sources, spectrum analyzers, etc. The oscilloscope can be used to analyze the arbitrary waveform signals emitted by this device's radio frequency system. The signal source can be used to generate a variety of test signals that can be captured by the device. The spectrum analyzer can be used to analyze the frequency domain information of the radio frequency field generated by the device. By connecting external devices, users can better understand the form of interaction in quantum systems and design various experimental parameters, thus making quantum experiments more accessible. The device offers a graphical interface for convenient quantum programming and learning quantum algorithms. In addition to this, deeper classical quantum hybrid programming experiments can be carried out through coding to meet different experimental requirements. SpinQ Gemini Lab comes with complete teaching resources, meeting the teaching model of university experimental courses, helping frontier quantum technology integrate into university education. The experiment handbook contains the theoretical knowledge corresponding to each teaching experiment, experiment content, operation steps, and reference answers. According to the contents of the experiment handbook, teachers can explain experiments, while students can do pre-experiment preparation, experiment operation, data recording, and experiment report writing. In experimental classes, through a series of teaching experiments built into the device, students can systematically grasp the physical principles of quantum computing, the application of quantum algorithms, and various quantum information measurement and control technologies. As a full-stack quantum computing experimental platform, SpinQ Gemini Lab provides students with professional and complete quantum computing experiment conditions. Teaching experiments cover observation of phenomena, parameter measurement, underlying operations, measurement readout, data processing, etc., and can fully cultivate students' experimental thinking. In the laboratory, users can also conduct topic or scientific research on quantum information based on the real quantum system of the device and its freely control method. As an experimental device with both teaching and research properties, SpinQ Gemini Lab provides convenient conditions for students' innovation and low-cost experiments for scientific researchers, inspiring quantum learning from theory to practice, advancing the cultivation of quantum professionals in higher education.